Hello and welcome to tutorial number 1 of the spatial model. The present film is the first in a series of short films that guide the user in the construction, setup and operation of the spatial model. Once you're done watching the movie series, you'll be able to perform the following. 1. Build objects in the spatial model. 2. Calibrate the objects to create a minimum of false alerts. 3. Identify spatial model faults such as ineffective spatial boundaries. 4. Identify a model with low prediction level. And of course, take the necessary measures to correct all of the above. So, what is the spatial model? The spatial model is a collection of objects designed to detect unusual behavior over a water network space. Abnormal behavior across the space is a situation where each station in itself seems to behave properly. But looking at relationships between the stations reveals an unusual situation. We will demonstrate anomalous behavior across space by a simple example. One way of maintaining water quality is by adding chlorine to water. Adding chlorine creates an oxidizing agent which destroys organic bodies. The main problem is that the chlorine evaporates in the water as it moves along the pipe. Thus, the concentration of chlorine decreases as you move away from the location where the chlorine addition takes place. For example, in the chlorine addition facility, the concentration of chlorine is 0.4 mg per milliliter, then within 10 km, the concentration can drop to about half that and even lower. How can the spatial model help in this case? Suppose that at a certain station, a measurement of chlorine concentration is obtained which is significantly higher than the station that precedes it upstream. There was probably no chlorine addition to the line. What is more likely is that the station is not calibrated. Furthermore, if the next station shows a lower measurement than both stations, it is clear that the middle station is not calibrated. The spatial model consists of two types of objects: pairs, and triplets. A pair is two stations, that are connected by a pipe, one or more. Triplets are two pairs which have a shared station. There are three types of triplets. Line triplet is three connected stations in a row. Fork-in is two stations that supply water to a third station. Fork-out is one station that splits into two stations. Within the spatial model, you will learn how to define and calibrate the different types of stations, to improve the ability to identify situations with exceptions. You will also learn how to generate communication between the spatial model and the EDS system, which is the hosting environment of the spatial model. There is another problem that the spatial model solved. In the last 40 to 50 years, managers of water networks are struggling with a very fundamental question: how long it takes for a drop of water to go from point A to point B in my network on a specific time. Why specific time? Because any network manager can tell you that the way the water network looks at the middle of a weekday is totally different from the way it looks at the middle of a weekend night. Different about what? Pressure, flow time, customers' demand, and as a result the amount of time it takes for a drop of water to go from point A to B. What tools and solutions science has to offer in order to deal with this challenge? The answer is very simple. It is called hydraulic model. What is a hydraulic model? It is a black box that if you put into it the exact topology of the network pipes, length, diameters, frictions inside pipe, and angles of pipe relative to horizontal, and also the demand for water at each junction in the network for each hour of the days and for each day of the week, and the power of each of your pumps, there is a good chance that this model will be able to estimate the flow time on the network. Is it feasible? You can see from the list of parameters that you have to supply to the system in order for it to work properly that this mission is almost impossible. Is there any alpha options? The answer is yes. Decision Makers has developed an alternative solution which is based on machine learning. The system learns the noise pattern of each station, based on correlation between noise pattern from different stations. The system can calculate the time difference, which takes for one pattern of noise, from an upstream station, to arrive to a downstream station. How it is done we will explain in detail later in this tutorial. What are the differences between the traditional methodology which is based on hydraulic model and this new methodology which is based on a spatial model? There are some pros and cons when you compare these two methodologies. 1. When using the hydraulic model you need to define the entire network. You cannot define just part of it, because the calculation in every junction is influenced by either its upstream or downstream junction, and if some junctions are missing, the overall calculation is wrong. With a spatial model on the other hand, you can start even with small portion of the network, and expand your calculation gradually. 2. The hydraulic model does not have learning capabilities. Basically, what you put in the model is what you get as a result. With a spatial model, the system has a learning capability, and it learns and improves itself over time. 3. The hydraulic model requires tons of parameters that you have to supply to the system before it can start do something. With a spatial model, the only thing that should be supplied to the system is the actual online quality measurements from each station. The system does the rest of the work by itself. 4th, there is some benefit of the hydraulic model over the spatial model. If you don't have historical measurements, there is not much you can do with the spatial model, because the machine learning technology is based on learning from actual data. With the hydraulic model on the other hand, can be used in the design mode because it can calculate everything from engineering parameters without historical data. Hence, the first task in the flow of construction of spatial model is define all pairs in the network. Once it is done, we can move to the second step of forks and triplets definition. We will learn about forks and triplets in the next tutorial. We hope that you will find these tutorials helpful and interesting. If you have any comments, please comment on our website.